Have you ever pondered on why software quality standards matter in the realm of software development? In an era where software is omnipresent and integral to our daily lives, the quality of these programs is paramount. Software quality standards are the unsung heroes in this story, providing a set of guidelines, criteria, and best practices that ensure any software product or process meets specified quality requirements and objectives. Imagine them as the rule book for a game, where the game is the complex process of creating software. They offer a framework that allows organizations to assess, measure, and improve the quality of their software development practices and deliverables. From functionality, reliability, and usability, to efficiency, maintainability, and portability, these standards cover it all. Their importance can't be overstated as they lay the foundation for high-quality, reliable, and secure software products and services. In this video, we will explore some of the most widely recognized software quality standards. First on our list is ISO IEC 25000, also known as SQUARE. This international standard is a beacon for software quality. It's broken down into two main parts. First, we have ISO IEC 25010. This part outlines a set of quality characteristics and sub-characteristics, such as functionality, reliability, and usability. These are all factors that can be used to evaluate the quality of a software product. The second part of SQUARE is ISO IEC 25040. This section provides guidance on quality requirements and evaluation processes for software products and systems. It's like a roadmap, guiding developers and organizations on how to ensure their software meets certain quality benchmarks. Overall, ISO IEC 25000 is a comprehensive tool that helps organizations measure and improve the quality of their software. It sets the stage for understanding what quality means in the realm of software and how it can be achieved. That's a quick look at ISO IEC 25000, a key standard in software quality evaluation. Next, we delve into ISO IEC 9126 and IEEE standards. ISO IEC 9126 is a well-recognized standard that offers a comprehensive software quality model. It's divided into two parts. The first, ISO EC 9126, 1, defines 6 fundamental characteristics of software quality. These are functionality, reliability, usability, efficiency, maintainability, and portability. Each of these characteristics is further broken down into sub-characteristics to provide a detailed view of software quality. For instance, functionality covers the attributes of suitability, accuracy, interoperability, security, and functionality compliance. Reliability, on the other hand, includes maturity, fault tolerance, recoverability, and reliability compliance. This detailed structure allows for an in-depth evaluation of software quality, making ISO IEC 9126 a valuable tool in software development and assessment. The second part, ISO EC 9126, 2, provides metrics and evaluation methods for these quality attributes. This means that not only does the standard define what quality looks like, but it also gives you the tools to measure and assess it. Now let's switch gears a bit and talk about IEEE standards, specifically IEEE 730, IEEE 1061, and IEEE 1633. IEEE, or the Institute of Electrical and Electronics Engineers, is another significant player in software quality standards. IEEE 730 provides guidelines for software quality assurance plans. It outlines the processes and procedures that ensure the quality of software throughout its development lifecycle. IEEE 1061, meanwhile, focuses on software quality metrics and methodologies. It provides a standard for developing and validating software quality metrics, which are crucial for measuring and improving software quality. Finally, there's IEEE 1633, which is all about software reliability engineering. This standard provides techniques for managing the reliability of software systems, including methods for predicting and measuring software reliability. In essence, ISO IEC 9126 and these IEEE standards complement each other. They offer a holistic approach to software quality, covering everything from defining and measuring quality attributes to planning for quality assurance and managing software reliability. These standards provide a robust framework for software quality assurance and reliability engineering. Now let's turn our attention to CMMI ITIL, and ANSI IE 1012. Our journey begins with CMMI, the Capability Maturity Model Integration. This model has two key components. First, we have CMMI for development, which provides a comprehensive framework for enhancing software development and engineering processes across organizations. With its holistic approach, it helps organizations streamline their processes, ensuring consistency, predictability, and effectiveness in software development. Next, we have CMMI for services. This model is designed with service-oriented organizations in mind, focusing on the improvement of processes in areas such as IT services and software maintenance. It provides a pathway to delivering high-quality services, integrating best practices to ensure customer satisfaction and operational efficiency. Moving on, we encounter ITL, the Information Technology Infrastructure Library. ITL version 3 offers a wealth of best practices for IT service management, including aspects of software development, deployment, and maintenance processes. ITIL provides guidance on how to align IT services with business needs, emphasizing the importance of continual improvement in delivering value to customers. Our exploration concludes with ANSI IE 1012. This standard defines the criteria for software verification and validation processes. Verification refers to the process of checking that a product meets specified requirements at each stage of development, while validation is the process of evaluating a system or component during or at the end of the development process to determine whether it satisfies the specified requirements. This standard ensures that software products are thoroughly tested and validated, fostering confidence in their reliability and performance. These standards play a pivotal role in improving software development and service management processes. Together, CMMI, ITIL, and ANSI IE 1012 provide a robust framework that guides organizations towards achieving excellence in their software development and service management practices. By adhering to these standards, organizations can enhance the quality of their software products and services, resulting in increased customer satisfaction and business success. Moving forward, let's talk about Agile and Lean practices. Agile is a software development methodology that prioritizes customer collaboration, adaptive planning, and iterative development. The Agile Manifesto outlines these principles, emphasizing the importance of flexibility and responsiveness in the face of change. It's a mindset that encourages frequent inspection and adaptation, allowing software quality to be continuously enhanced throughout the development process. On the other hand, Lean software development focuses on the elimination of waste. It looks at anything that doesn't add value to the customer as waste and aims to remove it. Efficiency is at the heart of this practice. It's all about streamlining processes, reducing cycle times, and making sure that every step in the process delivers value. In essence, both Agile and Lean practices aim to improve software quality by fostering a culture of continuous improvement and customer-centric development. Agile and Lean practices allow for enhanced software quality and efficient delivery of value to customers. Lastly, we have SEI standards, OWASP, and ISO IEC 27001. The Software Engineering Institute, or SEI, has developed a set of standards known as the Software Engineering Body of Knowledge, or SWBOK. This provides a comprehensive overview of software engineering principles, practices, and knowledge areas. It's like a treasure trove of information for software developers, encapsulating the collective understanding of the software engineering profession. SWBOK covers a wide range of topics, from software requirements and design to testing and maintenance, and even touches on professional practice and economics in software engineering. Next, let's talk about OWASP, the Open Web Application Security Project. OWASP is an international organization dedicated to enhancing the security of software. One of their most notable contributions is the OWASP Top 10, a regularly updated list of the most critical security risks to web applications. The OWASP Top 10 is designed to help software developers and organizations prioritize security measures and best practices. Think of it as a roadmap to navigate the often treacherous terrain of web application security. Finally, we have ISO IEC 27001, a standard that specifies the requirements for establishing, implementing, maintaining, and continually improving an information security management system. This isn't just about developing secure software, It's about creating a robust system to manage information security as a whole. It's about putting in place the policies and procedures that ensure your organization can protect its data effectively and respond to security incidents efficiently. In essence, these standards underscore the importance of a holistic approach to software quality. SEI SWBOC provides the broad foundational knowledge, OWASP highlights the critical security risks, and ISO IEC 27001 ensures a comprehensive information security management system is in place. These standards are key in ensuring software security and comprehensive knowledge in software engineering. So, what have we learned about software quality standards? In this journey, we've explored a myriad of standards that serve as guiding lights in the realm of software quality. From ISO IEC 25000, which articulates quality characteristics for software evaluation, to ISO IEC 9126, which provides metrics for assessing software quality attributes. We've delved into the depth of IEEE standards, with IEEE 730 focusing on software quality assurance plans, and IEEE 1061 providing methodologies for software quality metrics. We've also looked at CMMI, which offers a framework for improving software development and engineering processes across organizations. We've touched upon ITIL's best practices for IT service management, ANSI IE 1012's standards for software verification and validation processes, and Agile and Lean practices for enhancing software quality and responsiveness. In the end, we've discovered that adherence to these standards leads to robust quality management systems, improved development processes, and reliable, secure, and high-quality software products and services. So remember, the path to software excellence is paved with these standards.